Good morning, my dear students. In this session, we will discuss about glycolysis in details. So, glycolysis comes from two Greek words. That is, one is glykos, means sugar, and other one is lysis, means breakdown. So, glykos means sugar, and lysis means breakdown. So the term is self-explanatory. That is the breakdown of sugar molecule. That is called glycolysis. It is otherwise called as EMP pathway. EMP pathway, and it is named after the three scientists. One is Emden, Meyerhoff, and Parnas. So the glycolysis named after EMP, three scientists. That's why it is also called as EMP pathway. And the location, or you can call the site of glycolysis, is the cytoplasm. So location will be cytoplasm of the cell, and it happens both in the prokaryotes and the eukaryotes. It happens both in prokaryotes or prokaryotic cell and eukaryotes. And this is a pathway that is followed by both aerobic and anaerobic respiration. It is both aerobic and anaerobic respiration. And there are so many enzymes involved, and in this reaction, in this glycolysis, there are 10 enzymes and 10 reactions involved in glycolysis. So you can say 10 enzymes and 10 reactions. So 10 enzymes and 10 reactions are involved in the glycolysis process. And one thing is to remember that it is a partial oxidation of glucose. It is a partial oxidation of glucose molecule or similar hexose molecule. It's not the complete oxidation. Though it's not the complete oxidation, that means no carbon dioxide formation occurs in this process. And one thing, there is the release of both ATP and NADH. Both form of energy, that is ATP and NADH, are released in this process. And ATP you can say as the energy currency, and NADH you will study how we will encast this NADH to ATP. So these are the basics of glycolysis. So let's study in details about the glycolysis process. So the first step, that is the conversion of glucose molecule into glucose 6-phosphate. So glucose being converted into glucose 6-phosphate, and the phosphate here will be provided by ATP, adenosine triphosphate, and it will be converted into ADP. So the energy and the phosphate group are added by the ATP molecule, and this step is called phosphorylation. And the enzyme that is required for this conversion is called hexokinase. And here magnesium ion is required. So now the glucose molecule is converted into glucose 6-phosphate molecule. Now you must be wondering why this ATP is utilized here. In the process of glycolysis, there should be the release of ATP, but here the ATP is utilized. You have heard that money makes money. That means we have to use this organic money in the preparatory phase, then we get a lot of money in the final stage. So then the product, the glucose 6-phosphate, that will be converted into its isomer, that is called fructose 6-phosphate, and this is a reversible reaction, and the enzyme that is required for this conversion is called phosphohexoisomerase. And the process that is called isomerization. Here also magnesium is required. Now this is the isomer of glucose 6-phosphate. Now the fructose 6-phosphate will be converted into fructose 1,6 bisphosphate. And here you can see only one phosphate is attached to the fructose molecule, but here there are two phosphate, one in one carbon and other is on 6 carbon. That phosphate is also provided by ATP and it will be converted into ADP. So now for this conversation also the ATP is required, and the enzyme for this conversation, that is called phosphofructokinase, and magnesium is also required. And now the conversion of fructose 6-phosphate to fructose 1,6 bisphosphate is also called as phosphorylation. Now we get the fructose 1,6 bisphosphate molecule. Now the next step, that will the splitting of the breaking down of fructose 1,6 bisphosphate molecule. Till now all are 6 carbon compound. Your glucose 6-phosphate, fructose 6-phosphate and fructose 1,6 bisphosphate all are 6 carbon compound. Now it will split into 3 carbon compound, that is dihydroxy acetone phosphate and glyceraldehyde 3-phosphate. And the conversion, the enzyme required is aldolase. And the process of splitting of fructose 1,6 bisphosphate to these 3 carbon molecule, this step is called splitting. Now the next step is a isomerization step, that is the conversion of dihydroxy acetone phosphate to glyceraldehyde 3-phosphate. Now these both are 3 carbon molecule, and this is the isomer of dihydroxy acetone phosphate. The enzyme that is needed is called triose phosphate isomerase. These are the isomer, the reaction is called isomerization, and these are the 3 carbon compounds, so the enzyme is triose phosphate isomerase. Till now the reaction 1, 2, 3, 4 and 5. These 5 reaction, that is the half of glycolysis, is also called as the preparatory phase. Preparatory phase, or you can call it the energy consuming phase. It is because the energy is consumed here, so it is also called as energy consuming phase. Here the reaction 2 and reaction 5, these two are reversible, and reaction 1, 3 and 4 are irreversible. So next move to the 6 to 10 reactions. Just writing the fifth reaction, that is the conversion of dihydroxy acetone phosphate to glyceraldehyde 3-phosphate, and this is a reversible reaction. Glyceraldehyde 3-phosphate, and the reaction is called isomerization. Now the glyceraldehyde 3-phosphate is an aldehyde. It will convert into 1,3-bisphosphoglycerate, and this is an acid. And the conversion of aldehyde to acid is a which process? It's a oxidation process. So if the oxidation is happening, something must be reduced. That reduction is the NAD plus to NADH, and this is the hydrogen acceptor, and this gives the hydrogen, that it means this is the hydrogen donor. And the enzyme that is required for this conversion is called glyceraldehyde phosphate dehydrogenase, and the reaction is called as oxidation and phosphorylation. Now next step, that is the conversion of 1,3-bisphosphoglycerate into 3-phosphoglycerate. 3-phosphoglycerate. Here the position only changes. That means the phosphate will be there in 1 and 3 position, and here only 3 position. And the phosphate is being added with the ATP, and it will make ATP. So it is the first energy producing stage. So now we will get the ATP, and the enzyme that is required for this conversion is phosphoglycerate kinase. And this is a reversible reaction. So now the 3-phosphoglycerate will convert into 2-phosphoglycerate. And the enzyme that is required for this conversion is called phosphoglycerate mutase. Here only the position only changes, nothing else. The conversion of 3-phosphoglycerate to 2-phosphoglycerate, and this is also a reversible reaction. So now the 2-phosphoglycerate will convert into phosphoenol pyruvate, or PEP, phosphoenol pyruvate. And the enzyme required for this conversion, that is called enolase. And the enzyme required for this conversion is called enolase. And here also and the enzyme required for this conversion is called NOH. Now, this stage is also called as dehydration. Why dehydration? It is because a molecule of water will be released here. And this stage is called isomerization. That is the conversion of 3-phosphoglycerate to 2-phosphoglycerate. And the stage that is the conversion of 1,3-bisphosphoglycerate to 3-phosphoglycerate, where the first ATP production happens. It is called substrate level phosphorylation. Now, the last reaction, that is the conversion of phosphoenol pyruvate into pyruvic acid or pyruvate. Phosphoenol pyruvate, pyruvate to pyruvate. And here one molecule of ATP will be produced from adenosine diphosphate, and the enzyme required for this conversion is pyruvate kinase. And here magnesium, both magnesium and potassium are utilized. And here you can see the second ATP is being released. Now, this is a irreversible reaction. Now you can see from the 1-glyceraldehyde 3-phosphate, one pyruvate molecule will be released along with one ATP and the second ATP. 2 molecules of ATP and 1 molecule of pyruvate are released. But here the dihydroxyacetone phosphate will be converted into glyceraldehyde 3-phosphate. So this pyruvate will be from the glyceraldehyde 3-phosphate. Then the dihydroxyacetone phosphate will be converted into glyceraldehyde 3-phosphate, and again it will form 1 pyruvate and 2 ATP. So here the reaction, you can say 2 molecules are produced. So in the last stage, you can say from 1 molecule of glucose, how many molecules of pyruvate are produced? 2 molecules of pyruvate. Now we will see what are the net products of glycolysis. So this is the schema of glycolysis. So let's calculate how many ATP, how many NADH are produced and how many ATP are utilized in glycolysis. So input and output. So you can see I'm just wrote the ATP and NADH production and utilization. So here 1 ATP is utilized, here 1 ATP is utilized. That means input is 2 ATP. Now output and input is 1 glucose molecule also. And output, here you can see 1 NADH will be produced. And here 1 ATP and the second ATP. That means 2 ATP. But as the reactions or the molecules goes twice, and as the reaction goes twice, that means 2 molecule will be released. So 1 into 2 equal to 2 NADH and 2 ATP, that is 2 ATP into 2 equal to 4 ATP. So when you calculate how many ATP are produced, so 4 ATP will be output and 2 ATP is the input, that means the expenditure. So 4 ATP minus 2 ATP equal to 2 ATP. But here 1 NADH, if we utilize 1 NADH, we will get 3 ATP. In the later session, we will discuss how this NADH will help to encash the ATP. Now 2 NADH will be 2 into 3 equal to 6 ATP. So now the total production 6 ATP plus 2 ATP, substrate level phosphorylation. So total gross equal to 6 ATP plus 2 ATP. equal to 8 ATP. So 8 ATP production are happening. But this is for the case of aerobic respiration, where the sufficient amount of oxygen is available. But I already told that glycolysis is the common pathway. It happens in both aerobic and anaerobic condition. So now let's discuss how the anaerobic condition happens and how much ATP are utilized and released in case of anaerobic reaction. So from 1 molecule of glucose, we will get 2 molecule of pyruvate, and in this process 2 NADH and 2 ATP are produced. Now depending on the conditions of oxygen availability, that means whether there is a sufficient amount of oxygen is there or not, the pyruvate has different fate. If there is sufficient amount of oxygen is there, then the pyruvate will go to mitochondria, and there it will lead the Krebs cycle. We will discuss in later stage. And if there is this condition is called aerobic respiration, and if there is a scarcity of oxygen, that means pyruvate will get converted into 2 molecule of acetaldehyde. And here 1 molecule of carbon dioxide is released, and the enzyme that is needed is called decarboxylase. And the acetaldehyde again get converted into alcohol or ethanol. And here the NADH is used and NAD plus is produced. This NADH will be oxidized to NAD plus, and the enzyme that is required is called alcohol dehydrogenase. So this is called fermentation. Here the NADH that is produced in the process of glycolysis, that is being used up here. Now it is happening in the yeast cell. Now if there is scarcity of oxygen is there, or in the muscle cell, when you are running, you feel the cramps. You feel the cramps inside your muscle, and the muscle cell, the pyruvate has also different fate. The pyruvate can be converted into lactic acid, and here also NADH is used up. So the enzyme that is required for this conversion is called lactate dehydrogenase. So you can see there are different fate depending on the oxygen availability of pyruvate. If the oxygen is highly available, it will go to the mitochondria and perform further reactions. If the availability of oxygen is not there, it can be converted into alcohol in the yeast cell, and the NADH here is used. And if the oxygen availability is less, when you are running or doing some exercises, in case of muscle cell, it will get converted into lactic acid, and here also 2 NADH is used up. So these two reactions where the pyruvate has different fate is called fermentation and or anaerobic respiration. So you can see in the case of anaerobic respiration, only 2 ATP are produced. Why? It is because the NADH that is produced in the case of glycolysis, that is being used in the production of the alcohol, and here the lactic acid. The NADH is being used up. So when the question arises how many ATP are released in the glycolysis in anaerobic condition, you can say 2 ATP, and in aerobic condition it will be 8 ATP. So this is all about glycolysis. Hope you understand it, and in the later class we will study how this NADH will form the ATP, or how we will encase this NADH. Thank you.